Rajesh applies once every year for a ticket to a music festival. The probability that he is successful in any particular year is 0.3. So what I'm made to understand here, success. Okay, so this is success. So we have P is success, which is 0.3. Therefore, the failure is Q, which is 1 minus P, so that's 0.7. So we have a failure and success. So this is now, we know it's a geometric distribution if it's not a binomial distribution. How do we know? Because we have a 7th attempt here. Find the probability that Rajesh succeeds independently of other years. So all the trials are independent, and then we have a success and a failure. It's Bernoulli. Bernoulli means geometric distribution, I mean success and failure, and then independent trials. So that should be a geometric distribution. So we can write our distribution. X is geometrically distributed with mean 0.
Monsieur,
Yep.
si question partie géométrique qui binomial, mais comment les tes questions?
Wait, if it was a binomial distribution, you would have had a limited number of trials. Limited number of trials. If it was a binomial distribution. Limited number of trials, but over here it says here he applies once every year and then independently of other years. You're not being told how many years, you know. Although in practice this is very unlikely. In practice, somebody is not going to live forever. I mean, for as long as going to live, you know. So this is now unlimited. It's an unlimited number of trials. So that's how I know it's not a binomial distribution, because remember, for a binomial distribution, it will be x binomially distributed with n. N is the number of trials, so you know the number of trials. But over here, you don't know the number of trials. They don't normally give it to you. They leave it open. And then the probability of success is going to be P. But whereas for a geometric distribution, it's just P, the parameter. And the number of trials you don't know. You see? And they're all independent. That's the difference between a geometric and a binomial distribution. That's how I would recognize it. And again, you know, by the nature of the question itself, find the probability that Rajesh is successful for the first time on 7th attempt. When you get a question like this, 7th attempt, you know it's of a geometric nature. It shouldn't be a binomial. Okay, binomial distribution would tell you, let's say, okay, we'll come to that in other questions, but the main idea to keep in mind is this. Yeah. Unlimited, okay, unlimited number of trials. Right, so now we know that this is a geometric distribution. You're most welcome. All right, and what we want to find the probability that Rajesh is successful on the first time, for the first time. If he's successful, we have P. He's successful, right? And P is what? P is 0.3. Okay. For the first time on his 7th attempt. So the previous 6 attempts, he was not successful, isn't it? Because he was not successful because his first attempt was on the 7th attempt, right? So therefore we have Q, which is not successful, and that is 0.7. Okay, and then Q to the power of 6, because on those 6 previous attempts he was not successful. So this is a probability of, okay, first on 7th attempt. Okay, so first on 7th attempt is going to be all of that, and so we just have to plug this in our calculator. So let me just do it now. If I do so, I get, sorry, this is 0.7 power 6, so 0.7 to the power of 6, okay, multiply by 0.3, and I get 0.35, 0.0352947. So I'm going to say approximately to 3 significant figures, 0.0353, and so that should be my answer. Okay, I'm sure you understand this, all right? Okay, excellent. Now, find the probability that Rajesh is successful for the first time before, now look at this, before his 6th attempt. What is before 6? Basically, before 6 again would, let me just write this, x is geometrically, I mean, no need for us to write this now and then because I don't want to scroll up and down, so that's fine. Now, before 6 attempts, so that means probability of x being less than 6, right? And we know if it's less than 6, it should be probability of x being less or equal to 5, okay, because 6 is not included. Less than 6 means probability of x is equal to 0, probability of x is equal to 1, okay, probability of x is equal to 3, and so on until 5. Now that's quite a long procedure, okay, until you have probability of x is equal to 5. But before, I mean, instead of, even if you use this, you're going to be able to get the answer, but it's a bit time consuming. We also understand that the probability of x being less or equal to 5, it comes from a formula. I think I've explained that the last time to you. Probability of x being less or equal to x, okay, is what we're going to say 1 minus q to the power of x. So we're going to use this formula, all right, and it's very, very important that you remember this formula in the exams. So this is going to then be 1 minus q to the power of x, and x is number of trials, okay, a number of trials, and so that's going to be 1 minus 0.7 failure to the power of 5. So if we do that, 1 minus 0.7 to the power of 5, I get something like 0. No, hang on a second. Let's find the producer. Okay, okay. 0.839. Okay, I'm getting 0.83193. So maybe I'm going to say 0.832 to 3 significant figures, which is normally recommended by the Cambridge examiners. So this is our probability of x being less than 6 is first success. I mean, he's successful for the first time before the 6th attempt. All right, I'm sure you understand this as well, right?
Oui, monsieur.
Very good, very good, very good. Now, let's move on to this part of the question now. Find the probability that Rajesh is successful for the second time on his 10th attempt. Now, this is a bit tricky, all right? It carries 2 marks here, but let me just, we have 10 attempts, okay? Let me just put some boxes or maybe some lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, he's successful for the second time. So there on his 10th attempt. So this is like say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here he's successful. All right. So this is successful means P. All right. He's successful here on his second attempt. Second time he's successful. So the first time he's successful could be any of those 9 trials, isn't it? So we have then, what I'm going to say, in those 9 trials, we have 1 success. Let me just write this down in a different color for you. Here, I've got 1 success, and then 8 failures. All right, so we have one success and 8 failures. But he's got 2 successes. 2 success means the second success was on the 10th attempt here, right? So what I'm saying is that this is now the 2 success would mean p to the square. So p to the square, I mean p power 2 is the second success. I mean second success means that p power 2. And then we have 8 failures. Failures is q, so 8 failures. All right, and of course now we're going to be choosing the one on the first attempt, on the 10th attempt here. 1 success. He's successful for the second time, but we're looking for particularly on the 10th attempt. So this is 1 here, right? So I'm going to say then, no, hang on. This one is okay. One success is taken here. So out of 9 trial, so this is more like a binomial distribution now. Why? Because we have a limited number of trials. You can see there, all right? It's a limited number of trials. We have 9 trials, out of which 1 is successful. Okay, but then the success is coming to the square because we have 2 successes out of the 10. So that's a bit complicated. So I'm going to say then 0.3 to the square because it's got 2 success. And then 8 failures would then mean that 0.7 to the power of so 8. Right, if I'm not mistaken, that should be fine. Okay, because now 2 success. Okay, one of them is here and one of them is there. All right, so 1 success is there. You could do it like this. You could say, okay, 9 choose 1 out of 9 success. It's a binomial distribution. I got 1 success. So this is 0.3 to the power of 1. And now the second time he's successful is on the 10th attempt, but this is not out of the 9 attempts. So you got then 0.3. Okay, and of course the rest is failures. So 0.3 power 1 again. So now 0.7 is the number of failures. It's going to be 8 failures. Maybe I should have done this because I want to really make you understand something. Okay, so this is a binomial distribution. Successful in the 9th attempt is 1, and then failure is 8, isn't it? So failure is 8. 0.7 power 8. Then he's got 1 success on the 10th attempt here. So 1 success means times 0.3. Success is 0.3. Why am I putting 0.8 here? 0.3. This one is for the 10th attempt. He has 1 success there. Don't forget that. And so now we're just going to have to put this in our calculator. And let me just do it now. So I'm going to say 9 choose 1, okay, times 0.3 times 0.3 again, okay, and then times 0.7 to the power of 8. So I get something like 0.04669. So this is then 0.04669, and it goes on forever. 4, 8, 8, 8, and so on. So let me just say this is going to be 0.0467 if I were to wrap this up to 3 significant figures.